It's an interesting fault I found with this Marantz PM-45 amplifier. It's been one of the amplifiers that I repaired probably 4 or 5 years ago. It's been sitting in the workshop in the cupboard. I just thought I'd drag it out just to see, just have a listen to it really, more than anything. Switched it on, and it seemed to work fine initially. And apart from a slightly noisy volume control, which I squirt some deoxit in, but it's developed a strange fault. If I turn to Phono, I don't know what that's all about. It only does it on the moving magnet mode. So that's it's all part of this circuit over here. That's all the Phono preamplifier. Now I don't know what's happened. I've never come across anything like that before, but it looks like there's a loop stability and the amplifier's got a problem. I'm just having a look here. Let's put a torch so you can see. It looks like there's a bit of corrosion around there. Now you can see underneath that chip, that's a link wire. Let's get a bit closer so you can see. But there's a bit of corrosion there. Now, I've got a feeling that electrolytics vomited something all over the chip and it's causing a problem. So I think I need to get the Phono preamplifier apart, clean the board up and have a look to see if I can see if a capacitor's exploded. Can't see what else it can really be. Those two relays there in frame now look like they're the changeover switch relays that select a moving coil, a moving magnet. But apart from that, the amplifier works fine, but it's just that instability, high frequency instability on the moving magnet mode. It doesn't always do it actually, which is funny enough, but I need to sort of get that sorted out, because obviously if I have a sell this amplifier, it's going to be, and that's the other thing, see it's on Phono. Now that suggests to me when it's on Phono, I'm feeding into the CD at the moment, it's coming across on the Phono stage. Now that's a classic sign of something, electrolytics exploded, vomited its guts all over the board, which is conductive, and it's cross talking over to the other channel. So let's get this, I think we're going to get this preamplifier off. We have to be very careful with these selector switches, but let's have I'll have a look first to see if I can see anything obviously wrong, and then we'll investigate from there. Okay, I think maybe I know what this is, and probably a lot of you have already said, what about the glue? It could be possible that this glue is conductive. Now this is a problem with some of these glues they used on these capacitors, that becomes overage, becomes conductive. You can, I'm a bit overexposed on the camera a bit because the front panel is black, so I try to push the exposure a bit. But you can see that glue around the capacitor where it's glued to the board. I reckon that's become conductive. So I'm going to do a quick resistance check on that to see if it is conductive, and if it is, we're going to try and peel that glue off and see if that fixes the problem. Okay, let's measure across this glue and see if it's got any resistance. So I put the probes across the multimeter. So we're just touching across the glue. You can see that. Sorry, it's a bit 3.4 meg. That's not insignificant on a high impedance input, so looks like that glue's actually become resistive. So I think the thing to do is get the glue off, so we can scrape it off first, and see that stops the instability, and if it does, then we need to clean the board up, and maybe it isn't the capacitor that failed. These caps are usually pretty good actually, and it's in a cool area. It's not like the capacitor's going to fail. They're all in a nice cool area away from the power amplifier. There's the power amplifier down here. Just zoom out slightly so you can see a bit clearer. It's got one of these horrible, I hate these bloody things, these hybrids or whatever you want to call them. It's like a built-in amplifier that basically takes half the circuitry away. This is on the sort of like, I suppose you could class this as a hybrid amplifier where it's going over to sort of all just all IC stuff. Still got a proper output stage with the good old emitter followers and the output transistors, but it's got this preamplifier section here, this SDK3042, it's obviously a preamplifier. But yeah, let's try and clean some of this glue off and see if this fixes any of the problems we've got. Okay, what I've done is just basically scraped all the glue away. It was actually decomposing, actually. It was just flaked off. I scraped all the glue away, and I've cleaned the board off with isopropanol, and it seems to fix the problem. So that's the CD input, that's the phono, no problem. Moving magnet, no problem. So it's worth bearing that in mind with these old amplifiers. I know this is only a very short video, but this is this glue was used a lot in the amplifiers of this age. I don't know when they realised it was actually conductive and it was actually detrimental to the amplifier, but if you've got sort of strange problems like crosstalk problems and you can't find anything obviously wrong, if you come across this glue, it's not very easy to see in this light, unfortunately. Well, I can do this like anyone who knows Evo stick, it looks like Evo stick. It looks like a brown sort of semi-translucent glue. Remove it because it's conductive, or just stick a meter across it if you're not sure. Find some of this glue and stick it across. Stick a meter across it. There's some more down there actually, on this around these capacitors here. You can see that. See that glue there? That's the same stuff. Becomes conductive over time, but it looks like when it becomes conductive, it's actually in a breaking down stage, and you can just flake it off, which is good. But it doesn't always end up good if you've got a high sensitivity input, like you've got a sort of power supply next door to a very sensitive input. You could actually blow the input up by feeding in sort of current from the power supply and things like that. So yeah, worth a check, but it certainly seems to fix this amplifier. And he says speaking too soon, so it's still doing it. What I'll do, just to prove the point, I'm going to squirt the board with isopropanol. I wouldn't recommend this because the amplifier's on. There you go, stopped it. So there's something conductive around that board. So we still need to scrape some more glue off. But I think I'm onto something. That glue is definitely conductive and it needs removing. And then you can see this brown sort of deposit left on this capacitor here. This seems to be, I don't know if it's been reworked, this amplifier, but it seems to have something to do with the instability now. Can you hear this click in the background? Sort of like a low frequency instability, and it's only in the right hand channel. If I touch into that, it's getting slower and slower, but let me just show you what I do if I touch it. I think it's something to do with this. It's getting slower and slower, and the stability is about to stop, but there's something wrong here. And I don't know what all these gunges on the board, so let's give this board a clean up this side as well. Right, I've cleaned off what I can see as the excess of the glue, and I've cleaned the back of the board, which looked like flux, but I'm not convinced, so I've cleaned all that off. There's still a bit of a problem. It's not motorboating or oscillating anymore. But if you listen to when I turn it over to phono, if you listen carefully, let me just turn it over so you can hear, sorry. Hear that click? That shows there's signs of DC offset on the amplifier, and that can be proved by, I wouldn't recommend doing this, but this proves the point. If I turn it to phono and turn the volume up quickly, here, listen. Hear the click? The amplifier went into protection, and basically what the amplifier did was it detected there was a high DC offset on the output and disconnected the relay from the speakers. And that's because speakers will not tolerate a DC voltage going through them. And it's also detrimental to the amplifier. It's obviously passing DC current through one of the transistors, and they're not designed to do that. So that means that there is a DC offset on the phono amplifier that we need to sort out, and that's probably still down to contamination on that board. On a normal, funny enough, on an amplifier like an amplifier from the sort of like the 60s and 70s, or even 80s actually, a capacitor coupled amplifier, that wouldn't happen because the capacitors would block that DC signal. But due to the demand for direct coupled amplifiers, where basically you put a DC signal in on the input, you get a DC signal on the output, it's become more sort of popular to have amplifiers that have no capacitor coupling on the audio stage, and therefore if you put any DC on the input, it's amplified at the same exponential value as it is for an AC signal, and that appears on the DC output, and that can damage the amplifier and the speakers, but most likely the speakers. So that board's going to have to probably be stripped. I'm going to leave it overnight because I have actually scrubbed the board pretty thoroughly, and it's possibly still contaminated with isopropanol, but the board looks pretty clean. If you can see here, it's not very, the light isn't great in here for this sort of thing, but most of that glue has been removed, and it's mainly around the capacitors. They only use these glues around sort of large mass components like this electrolytic here and this capacitor here, just to dampen vibration. The main board, apart from around those electrolytics there, is pretty free of it, and that can be scraped off fairly straightforwardly, but that's always worth bearing in mind. These capacitors can go leaky, and it's not necessarily because of the capacitor, it's probably because of the adhesive they used. Oh, and it's just tripped into protection again, so I'm turning the amplifier off. Okay, I've removed the record playback circuit board, and I've got access now to the Phono amplifier here, and you can see the Phono amplifier is down here. Let's give you a bit of extra light so you can see. So we've got a JRC, that's Japanese Radio Corporation, looks like a 7028, I think that's the part number of it, that chip there, sorry, in the centre screen. You can see the glue around the capacitors next to that polystyrene in the electrolytic. You see all the gunge build up there, so we're going to give that a scrape out there. You can see it's run down the bottom of the boards and the back there, but that shouldn't cause a problem because there's no tracks there. So we're going to clean all that up and give it another scrub out. It's still running unstable on the Phono amplifier. Now it could be that the chip's actually packed up. Now the common chip with these was the 4559 that your Technics amplifiers use, but this might be an updated version because this has got a moving coil amplifier in it, and the Technics amplifier I replaced the chip before didn't have a moving coil amplifier, so it might be a moving coil amplifier. But all the electrolytics look okay. There's no sign of any leakage or anything like that. And these caps are pretty good, and as I said, they're running in a cool area, so they shouldn't cause a problem. So let's try and get some of that gunge out. You can see there's a bit of verdigris there, where it looks like the corrosive action of the capacitor is the glue has actually attacked the tin copper link that you can see there. You can see all the way around. You see that resistor to the right of the capacitor has gone a bit discoloured. So it's clearly this capacitor is highly corrosive when it breaks down, and it's exactly what you don't want on an amplifier. And this was the Japanese's idea of inbuilt obsolescence. You know, the glue would break down after years, the capacitor amplifier would fail, and then you go and buy a new amplifier. Though I doubt that very much, to be honest with you. Okay, this is one of the capacitors on the Phono amplifier. I've just removed just for checking. Capacitance measures about right, but its ESR is quite high. That's a microfarad capacitor at 6.3 volts. I expect the ESR to be quite low, and it was a, let's say, actual dissipation factor on the HP analyzer, the capacitor checker. So I'm replacing it with another capacitor, new capacitor, one of these 1000 microfarads at 10 volts. Obviously the difference in size over the years. So I'm going to replace those two capacitors because I can't really see anything wrong with anything else. I reckon it's probably a capacitor that's probably a bit high resistance, and it's just making the thing sort of unstable. So that was, the capacitor was here. I'm going to remove this. This is C, I think it's C401. Where are we? C405. It's not that clear on the circuit, unfortunately. I can't really get you that much closer. But if you look at the gate of that transistor there, you can see that I think it's 405 is there. It's on the gate of that transistor on Q403, and that would, in theory, affect the stability. And that goes back to the, I think that's the output of the or the input of the Phono amplifier. So I'm going to change these two capacitors. and then I'm going to go through the rest of these smaller capacitors. They're going to be more likely the ones that failed. There's little ones down here, these two here, possibly gone high resistance. I'm hoping I can replace it with maybe a ceramic or something that's a bit more reliable, maybe polyester ideally, but ceramic would probably also work if we can find anything. It depends what value they are. These two here will have to be replaced with electrolytics. So let's change these two capacitors. So it's this one here that I've just removed on where are we there, and this other one here. I'm going to change those two, and then we'll see what it does. I need to check the voltages on this chip. I had a quick look earlier on, and some of the voltages didn't seem to be right. When I had the circuit board out of the amplifier, it wasn't easy to check the voltages without shorting anything out, so I didn't want to risk blowing the amplifier up. So I'm looking at this Q405, and it looks like a regulator of some description. I'm not entirely sure, but it's got voltages clearly marked on all the pins. I'm assuming it's some sort of like little switching regulator maybe. I assume that the inputs are the 14 and the minus 14, and there's the 0 volts on pin 1. So I'm going to go through, and but I can't show you sort of me doing it at the same time, but I will show you the meter, and I'll call out the pins I'm checking. So if you're we're looking for 0, 5.3, 5.3, minus 14, 5.3, 5.3, 0, and plus 14. So I'm going to go onto the meter now. I'll set the camera up to show you the meter, and I'm going to read out what we get. Okay, bear with me a second whilst I try and get this to work. So we start on pin 1, and I'll read you through which pins I'm looking at. So this is pin 1. This is basically 0. Pin 2, minus 7.48. Pin 3, minus 7.47, basically the same thing. Pin 4, 14.25, that's correct. Pin 5, 200 millivolts. Pin 6, careful not to short anything out, minus 200 millivolts. Pin 7, bear with me, pin 7, 12.89, and pin 8, minus 14.65. So, to me, that looks like that chip's failed, unless there's a short pulling it down, and which is the next thing I'll check. I'll do some DC resistance measurements on, but it clearly looks like that chip in there, which is this dual inline chip here. Let's turn it far off so I'm not shorting out. I'll get a torch so you can see. Where are we? It's behind those two polyester capacitors there, that chip there. Looks like the regulator, that one there, that 8-pin dual inline, has failed, and that's causing a problem with the Phono amplifier. So I think the next thing to do is to try and look up the information on that chip and see if we can work out what it is. Oh, it's not an op-amp. It's not a regulator. And it was not going to be. It's bound to be in an op-amp. I was thinking it was going to be a regulator. So here it is. This is an NJM2041, and it's a dual op-amp, low noise, designed for the Phono amplifier, and it's clearly, looks like it's clearly got a fault with it. The voltages aren't the same on either side. You'd expect them to be the reverse, because you've got the two inputs of the op-amp and the pin 7 and pin 1 on the outputs. It looks like pin 8 and 4 are the supply, but I'm not getting the right sort of readings. They're all over the place. So I need to double check that before I order another one, but it looks like you can replace them with the TL041, something like that, dual op-amp. Need to check, see if there's a cross-reference. This chip isn't readily available on sort of like from RS or anything like that, Farnell. It does look like you can get it from Mauser. I haven't got a Mauser account. I don't really want to set up another account, just order one chip. but it's clearly yeah, an op amp, isn't it? It's nothing else. Now the only thing I can think that could possibly have caused that is that it has got a FET front end that goes to this, drives this chip. Let's have a quick look at the circuit. So let's find this bit we're interested in. Where are we? Let's find the phono stage. Bear with me a minute. Okay, so that's the phono stage there. So the input is here and here. It goes to these two FETs. I'm not sure what these FETs are doing. What are these FETs doing? Actually, they're a voltage regulator, aren't they? Looks like they're a voltage regulator for this chip that we were discussing. So the supply to the chip looks okay. So I think those FETs are probably fine. I think that this chip's been plugged into a high-level source that's blown it up. Let's just have a look. There's the input. Maybe they're not. Not entirely sure. Work out this circuit diagram. But these levels were not what it says here. These are obviously the voltages you're expected to see. These two diodes have been checked. They appear to be okay, as are sort of that resistors around it. So it does initially look like this chip's faulty. So I'm going to try and track down another chip, and we'll go from there. I removed that op amp that I suspected was faulty. Didn't have the same op amp in my stash of stuff. For those who are interested, it is a, well, it's the new equivalent number is an NJM2041. It's made by JRC. But I've also what I did have in my stock was a OP271, which is a dual op amp. And compared the pinouts are the same, and the voltage was the same, and this one's got a slightly lower frequency response or frequency range. This tops out about 4 meg, I think, and the other one was about 5 megahertz. Though, as it's operating in an audio amplifier, that's by the by, to be honest with you. So we've yeah, you can see I've installed it on a header there, and the only problem is it don't bloody work, does it? It's got the same fault. We've still got the same problem. If I switch it on, I'll show you. So we're on a moving magnet at the moment, and we've got a fly stuck inside the speaker by the sound of it, and it's something to do with that op amp, or something to do with the gain around that area. So the only thing I can think of now is, I mean, the capacitors seem to check out okay. We've got these FETs here. I need to check those. So I think the thing I'm going to have to, I don't really want to remove this board totally because it's a bit fragile, and these connectors here are buggers to get back in again. So I'm going to have to try and check the transistors and see if any of those are okay. But I think all they are muting FETs. But I'll have a look at the circuit and let's see if we can work out what's going wrong here. We see these two resistors on the drain of these two FETs here, 414 and 412. They're supposed to be 4K7. I don't know if it's the glue that's damaged these, but if you look at here are the resistors I'm looking at, and you see that one's actually sort of broken apart, and there's a lot of sort of like corrosion and stuff around there. Now these are tiny little resistors. They're like much smaller, like a TR4 or something like that. So we're going to have to cobble something in. But it doesn't also look like there were a 4K7 on here. I need to get the resistor out and check it. There is obviously one on the other side of the amplifier, and it's those resistors there. But they don't look like 4K7 either. They've got a blue band in them, so I don't know if this is like an updated amplifier or something. So get those two resistors out, and I think what I'll do is I'll lift one end of those resistors, measure them, and then I'll put back what I found there in there, and we'll try it again. Okay, I replaced those two resistors with like an MFR4, I think they are, TR4 sort of quarter watt equivalents, good quality resistors. it works now. It sounds like it's working both channels. The simplest way to do that is just to have the volume at a reasonable level, and we just stick a screwdriver or something into the phono socket and see if it buzzes. It's something that I can actually contact. This is quite a good sort of signal injector system. Got right channel, got left channel. That's fixed the phono amplifier, that's good. Now I think what I'll do is I'm going to put back the original op amp, just because there's obviously nothing wrong with it, and it was obviously the one they designed it for. Put that back in, screw it back together, and we'll try the phono amplifier. Now I've actually got a turntable turning up probably Monday. It's Sunday, Saturday evening now. A chap at work's asked me if I wanted a Pioneer turntable, and I think I know the turntable he's talking about. I think it's a PL12D, which is quite a famous sort of late 70s, early 80s Pioneer turntable. Quite a good quality turntable actually. So maybe we'll plug that in and try the amplifier on the phono input and see how it does. Obviously it won't be trying on moving coil, but we'll certainly try a moving magnet. So let's get this chip replaced with the original one, and we'll see if it still works. Okay, the JRC op amp's back in, let's try it. Beauty. Okay, so the preamp seems to be working, the phono amplifier stage seems to be working, so let's get it back together and we'll have a listen to it. Okay, I've connected the Roden Schwartz audio generator up to the phono input. Obviously I can't use a normal line source because the level's very high. I suppose what I could do is actually run it through the attenuator. I could demonstrate that if you wanted to hear the audio. What it would sound when I play it back through the phono amplifier, because the phono amplifier has an equalizer built in, it's going to sound very bass heavy and very treble light. But I'm running through with the audio and the signal generator at the moment. I'm putting in this is 98 Hertz at 7 millivolts, which is about the input you'd expect for a phono amplifier. Both channels are working fine. The moving magnet and moving coil amplifiers are both working by the seams of it, so that's good. So what we will do, and alright, we'll put some audio through it, and as I say, it's going to sound a bit odd, but it should prove the amplifiers are working properly. Okay, got a line level going in, and you can hear the amplifiers working. Both channels, as I said, it's very dull because the equalizers in effect the RIA equalizer, which basically boosts the bass and cuts the treble to reduce, basically because a record can never produce a huge amount of bass because it's limitations of how much the stylus can actually move in the groove, and the treble cut is to reduce background noise and hiss and crackles from the actual playing of the record. So that equalizer was introduced in the early stages to compensate for that, and it's been around ever since, and it works quite well. But that's why you can't use the phono amplifier for anything else than the phonograph. Let's turn the tone controls on actually. Turn the bass down, the treble up. Still can't get enough boost on it. There we go. Pretty nearer what it should sound like. And obviously I've got the record playing slow so I don't get a copyright. But no, the amplifier's working again. So that was all but down to this conductive glue. And this is what it looks like. I've just used some around this capacitor here. Initially some people think it's the capacitor's leaked. No, it's not that. It's actually a glue, and it looks a bit like Evo stick. If anyone remembers what Evo stick looks like, when it's new it looks like Evo stick. So it's like a sort of clearish brown liquid, but with age it goes to sort of discolors and then it becomes conductive like this. So it's worth, if you've got an amplifier that's messing around, it's worth checking that it hasn't got this awful bloody glue on it. One more thing I would like to point out on this particular amplifier. This is a direct coupled amplifier, which means that all these terminals are above chassis potential. And the reason why I'm pointing this amplifier out is most amplifiers have got a sort of like a much larger insulated area, and you can see here that this wire I put through, it only has to short to the chassis, and you could blow the output stage up. I mean, it would probably protect itself, but if you've got these sort of connections on these amplifiers, you need to be absolutely sure that they're in properly and they're not going to touch to the chassis. It's a pretty poor design actually, and that really needs to be, as I say, most of them have a larger sort of, like the whole back panel has the mountings for these insulators, and they're usually all plastic, so there's no chance of it shorting to chassis. That's about it really. I think I'm going to go around and clean up some of this conductive glue on here, just make sure it's not going to cause any more problems. But quite a nice little amplifier this actually, this Marantz PM-45. Probably not one of the best amplifiers they've made, but certainly not bad at all. Anyway, thanks for watching, more to come.